Although we can't say exactly what the composition of Earth's atmosphere was 4.5 billion years ago, we can assume that these gases came from prehistoric volcanoes. We can observe today that magma has various gases that are dissolved inside of it, such as carbon dioxide, water vapor, ammonia, methane. And when we combine that idea with our knowledge of how pressure and temperature relate, we know that if temperature of a system decreases, so does pressure. It's this exact same phenomena that caused those gases to be released into the atmosphere. When the Earth was first formed, it was still very hot and molten, but over time, temperature decreases and it radiated away. Because of that, pressure on the magma in the Earth's crust decreased and allowed the gases to escape into the atmosphere. It was these various gases that were released into the atmosphere that became the building blocks of our atmosphere today, such as water vapor. Water vapor condensed to form clouds, and it came onto the ground in form of rain, and it formed shallow oceans that covered the entire globe. Something like nitrogen-based gases, which were either picked apart by UV radiation or just simply reacted with other atoms in the air. It allowed free nitrogen atoms to bind and form N2, and in our modern day atmosphere, N2 makes up about 78% of the atmosphere. Lastly, another very important gas in the atmosphere at the time was carbon dioxide, which made up about 25 to 50% of the atmosphere. Much of it was dissolved into the ocean, some of it stayed in the atmosphere, but carbon dioxide plays a very important role in the next slide. Speaking of the next slide, you may notice that there's a specific gas that I haven't mentioned so far, oxygen, and this is where the great oxygenation event comes in.